and what's the kind of solution that we came up with. We'll talk about the self-service analytics platform provisioning that we developed in-house to solve some of those problems, and then we'll get into how we are starting to use Cloudbreak more and more for solving some of our problems. We will finish with some of the monitoring and alerting that we have built around these platforms. So quick introduction, Symantec. I'm pretty sure a lot of you have heard about Symantec before. It's definitely the world leader in security software for both enterprises and end users. And there are pretty much most of the Fortune 500 companies are customers of Symantec at this point. There are close to 400 million endpoints that are using Symantec software today. CPE within Symantec was charted with building a consolidated cloud infrastructure and platform services to take all of the Symantec products to the next generation. And the big data platform that we provide within CPE is used for both batch and streaming analytics, and it utilizes both private and public clouds at this point. And CPE is primarily built all of its tools and software completely on open source. We bridge gaps in open source, and we contribute back as well. All right, so big data platform challenge, what do we face, right? So as you can imagine, there are hundreds of millions of endpoints that are running Symantec software, so we get billions and billions of events every day across the globe, right? And Symantec is an engineering organization. There is close to 7,000 engineers at Symantec, so as we scale this platform, there are more and more developers that are wanting to come onto the platform, right? And they're developing thousands of applications every day. Right now, CPE has more than 500 plus nodes, and it's got the largest security data lake within Symantec at this point, right? And we have to make sure that we have elasticity built into this cluster, specifically when we go into cloud, to make sure we can optimize the costs, right? So these are some of the challenges that we are running into, right? So now we are building these clusters, and so we did have our first production cluster that I was saying with 500 plus nodes and 12 petabytes and everything. It's all in there. Now the developers are coming in. They can start using our big data lake. We have hundreds of developers building applications on different data tools. So this is like a little snapshot of what it was in April, right? So as you can imagine, the big data world is changing very, very fast, right? So there is a new version of some open source project that comes in every other month. And as a product team developer, they always want the new versions that comes in. There are some new features that they're interested in, they always want to use. So, but as a platform team, how can we manage all this, right? So there's so much new software that is coming in every other day. What happens, right? So there is some frustration, right? So because we always want stability, but the platform team, they always want the new code, the new software. So how do we solve this, right? What if we build a little cluster for each of these individual developers as a new software comes in, like a new version of Spark, new version of Zeppelin, whatever that comes out, or a new version of Storm or Kafka, if they can build their own little cluster, play with it, and make sure that it's all stable, it's all good, we have a good way of monitoring everything around that, and then say, this is all good, then we can go back and enable it in the platform because we have a good level of confidence at that point, right? So the solution we came up with is we'll figure out a way to build a little cluster for each of those developers. We'll copy the subset of data for their development purposes. And we will also build elasticity into it, depending on their need. And then once that project is complete, they'll tear it down, and then we'll repeat and rinse the same process over and over, right? But building the cluster is not easy. We can't just go to the product team and say, hey, you build your own cluster and test your software, right? So because it is too complicated, it runs too many services, there are too many configurations that you have to tune, and developers are not interested in that. They are interested in developing applications, not building and managing clusters, right? So, but what if we make it really, really, really easy? We automate everything, we abstract all the complexities out of it, and we just give them, like a service that they can use and click like 3 buttons, and then they get their own cluster, right? At the same time, if we can standardize the blueprint such that we can use the exact same blueprint for both their clusters, and then also when we go to production, so that we know that the versions of the software and everything is exactly the same, right? So that's where we come into the self-service analytics platform provision, right? So this is something that we developed in-house as part of our journey to solve this problem. So this is basically, SSA is basically a bunch of RESTful web services that allows creation and management of custom clusters for your need, right? We have a predefined Ambari blueprints based on the workloads that we have seen in the production platform that people are using. But if there is a different, blueprints that users need, it's very easy to go in and add a new blueprint to the service. And this service can actually provision infrastructure on both OpenStack, which is our private cloud that we use, and then it can also provision infrastructure in AWS. It basically installs the HDP stack specified as part of the Ambari blueprint, and then it also has a dashboard to monitor and manage the clusters. So in a quick nutshell, this is the environment that we operate under. So our private cloud is built on OpenStack, Kilo release. It doesn't have any heat templates. We are right now experimenting with AWS, and I assume that we'll probably be also experimenting with a few other clouds as well. Right now we have some clusters in 2.3.2 and some in 2.4.2. And those are the two different versions of Ambari that we're using. So this is a quick architecture, really high-level architecture of SSA. It's a very simple service. It basically, as a user, the user would call either OpenStack or they will have the AWS key for their own use. They would just authenticate and get the token, and then they would just pass in that token to the SSA service, right? And when they give the SSA service, there are a bunch of APIs that they can execute, and then based on the APIs, some of the actions will happen on one of these clouds, right? So it's either it will create a new cluster or get the status of the existing cluster and things like that. So basically what it would do is, once it gets a token, it calls the specific OpenStack APIs or AWS APIs to spin up the VMs, and then it also installs the Ambari server and Ambari agents, and then submits a specific blueprint that the user asked for. SSA also has its own metadata store on the back end. It uses MySQL. Excuse me. So these are some of the services that SSA has today. And as you can see, it's a very simple list. A user can come in and get a list of clusters that they have. They can get the details of the cluster, and the template is very similar to an Ambari blueprint, but it has a little bit more information for us to use. And then you can get the list of templates available today. You can get the details of a given template. There's a service to create a cluster, get a status of the cluster, and also there is an API to delete the cluster once you're done. Right. So let's just go through a very quick demo. We have the demo recorded since it was a little bit complicated to run it here with our VPN and everything, so I thought we'll just record. So here's the demo that's going. So basically, it's what you're seeing is a Postman REST client, and this basically is a simple submit to that REST endpoint with all of the information in the post body, and it basically says, what version of what region you're using, what's the blueprint, and all that. So once it's done, you can see it is all. We just went to the AWS UI. You can see it's actually starting to spin up the VMs. You can see the VMs are coming up as soon as we submit it, and then you can actually go back and get the status of the cluster. So there is actually a few other steps between this. For the sake of time, we kind of cut some of those. So actually, you can see when you go back and get the status, once a cluster is completely ready, it will probably take about 10 minutes. You can see the cluster is active, and it will return you the Ambari URL. Now you can actually go to the Ambari URL from there, and it actually goes in, and you can see that the services and the blueprint that you requested for is being installed right now, right? So in a nutshell, that's kind of the way that we really wanted to make it really, really easy for the users, where they just come in and say, here's this one call, and then give me the cluster, right? In 10 minutes, they can check the status. In 10 minutes, they come back. They have the Ambari URL. They have the cluster ready. And the one that we just showed was for AWS, and we're just showing right now here how easy it is to change that to work with our private cloud in our OpenStack. So it's the exact same call. You just go in and change the network name, the the cloud provider name, and obviously the flavors of the VMs are different between AWS and our OpenStack, so you just change the flavors. So for each of the host groups within Ambari, you can actually specify the flavor that you want to use. You just go in and specify that, and then you just call that API again. And obviously, I'm giving a new name for the cluster, so the name is unique for each of the cluster that you spin up. Again, so this cluster was submitted successfully. Now we'll go back to the UI in OpenStack, and you can see actually the new instances should be spinning up pretty soon. And it's the same thing. Beyond this, it's exactly the same thing where, after 10 minutes, you will get an Ambari URL, which is primarily pointing to the OpenStack instance of Ambari, right? So this is kind of, the journey that we started. So basically, we wanted to make it really, really easy. We don't have a nice UI for this yet. We're kind of building some UI using Rundeck at this point. But essentially, a lot of our customers for the platform team within Symantec are other engineers within Symantec, right? So they're very well trained in REST API, so we decided we'll just stick with REST API to begin with. All right, so this is all good for the services that HDP supports or Ambari supports, right? So there are services that Ambari by default supports, but there are also other services within our platform team that we support that's not included in Ambari or that's not managed by Ambari at this point. So how do we solve this? We actually started writing a lot of Ambari custom services for some of the services that we support. For example, in this screenshot, you would see we have a Cassandra service that we deployed using Ambari, and it's a custom service that we developed. We've actually open sourced a lot of this. You can actually go download this from Ambari Gallery if any of you are using Cassandra or a few other things we have for Elasticsearch and things like that. So this actually gives us a good way to control, and manage the services that are running in the platform in terms of what versions it's running and how do you manage it, monitor it, alert it, all that stuff. Right. So this is all good. Now we are thinking about how do we make it so that it's easier to go to the hybrid cloud, right? So we started with OpenStack and kind of did it into AWS, but now we are thinking about what about other cloud providers. We need to really look at the cost optimizations. Which of the cloud providers is cheapest and the most efficient? We are probably going to go with that, but we need to figure out. So we started looking at Cloudbreak as a tool. So Vivek will talk more about how we are using Cloudbreak.
Yeah, thank you. So like Karthik said, we started with developing our own in-house solution for cluster provisioning and provisioning of HDP stack, which all look great, but it involved a lot of work to maintain that and add features to it. And if we are to choose a different cloud provider, we would end up spending like few man-months in developing a plugin for the new cloud provider. So we started looking for options, and Cloudbreak kind of provided what we wanted to do. Basically, what we get from Cloudbreak is it helps us simplify the provisioning of the HDP clusters. It basically supports AWS, OpenStack, Azure, and Google Cloud. We use AWS and OpenStack right now quite heavily in our environment. It deploys the HDP using Ambari and something which our SSA did not have. It has a nice UI to manage the clusters. Apart from that, it supports some level of cluster scaling, so we can add scale up, scale down cluster depending on the load on the cluster. So that was helpful as well for our production clusters. So this is the end result that we wanted to achieve using Cloudbreak. We wanted to deploy clusters in AWS primarily, which is on the right-hand side here. Within our own VPC and within a private subnet. Basically, we use some large flavors and encrypted volumes, non-EBS root volumes. All our installations of HDP are non-Dockerized. Cloudbreak, when we started using it, only supported Dockerized HDP. And we use our own AMIs to deploy, our own hardened AMIs to deploy our clusters. We also have a fat pipe, a direct connect pipe here, a direct connect pipe which connects us back to our data center, which is still hosting our legacy cloud, which is on top of OpenStack and bare metal, again an HDP stack. So we have data ingestion pipelines that pull in data over this direct connect pipe and pushes it out to the hybrid cloud, the public cloud. So we wanted Cloudbreak to help us provision cluster on AWS primarily. So we started looking at it, and we found that there are few things that Cloudbreak still did not have. So we worked pretty closely with Cloudbreak team and they were very supportive to help us get this feature out. And I'll show first the demo before I go to what exactly are customizations that we made to Cloudbreak. So this is basically the Cloudbreak UI, and we'll see how we can build a cluster using it. So we select a credential which is already saved called ADL production, and we start setting up a cluster. We select the region where we want to create the cluster. This basically will create the cluster on AWS US East. So the CP production is the VPC. So this is where we select our VPC, and this will make sure that Cloudbreak deploys this cluster in this particular VPC. And then moving forward, we can select the blueprint that we want. You can save your own blueprints, select whatever you want, change the flavors here, and then few more steps which you can do here. And finally, it will just go ahead and kickstart this. So there are a lot of customizations that you can do with respect to how you want your blueprint to be deployed. Here, we just go ahead and select do not validate blueprint to speed things up here right now, and it will just go ahead and here it goes. You can choose failover actions, configure other properties, and finally, okay. Now it has gone and send out the calls to AWS API to actually deploy the cluster, and we'll see very shortly that the cluster is being deployed here on the Cloudbreak dashboard. We can see what is happening behind the scenes. Here it has created the infrastructure. I basically cut short few parts in the demo to keep the demo short. Once the infrastructure is deployed, it will deploy Ambari. This will show the progress of Ambari deployment and an Ambari URL. Exactly like what we did in our SSA. When you log into Ambari, you can check the status of what is going on right now. So it's still in progress. We see a lot of operations going on here. And the Ambari right now is deploying all the components depending on the blueprint that it was supplied. So once we have the Ambari deployed, we'll see a message saying Ambari cluster built, and that is when we see all green in Ambari as well. So yeah, so this is where we see that all components are now deployed and they are up there. So once we have the cluster running, if it's a dev cluster, you can terminate it through Cloudbreak as well. So this shows how you terminate the cluster. You just select the cluster, hit on terminate, and it will just go ahead and destroy all the infrastructure that it has provisioned on AWS. So that's about the demo. I'll quickly go over. This was the end state that we achieved using Cloudbreak. We deploy not only the dev test clusters, but also the production and staging clusters using the same tool. So now I'll go ahead and see what kind of customizations we did. First of all, like I said before, when we started using Cloudbreak, it supported only HDP installation on Dockerized containers, which we did not want. We wanted it to be installed on our regular non-Dockerized HDP. Our private cloud, OpenStack, which is OpenStack, runs Keystone version 3. Cloudbreak didn't have support for it initially, so we contributed that back. It's now available in the released version of Cloudbreak. Cloudbreak, there was no support for customer AMIs, so it basically uses some default AMIs, which has some configurations specific to Cloudbreak. But we have our own hardened images, which have enhanced networking, volume encryption, etc. enabled. So we have to use that as per the org mandate. Also, the root volumes that Cloudbreak deploys on AWS, the infrastructure, it uses an EBS backed root volumes, which is something that we did not want. Our mandate is to use a non-EBS backed root volume, so we made some change that we'll see to the CloudFormation template that Cloudbreak uses for this. Then when initially Cloudbreak did not, what we saw in the demo where we selected the network, that option was not there before, so Cloudbreak team helped add that feature to Cloudbreak, and we tested that out in our environment, and that is what we are using here. Then the flavors that we are using are basically R3 and D3 star, which were not supported by Cloudbreak. We added support for that as well. And because of all this customization and contribution, we obviously run Cloudbreak from trunk, and we are not using the released version of Cloudbreak. So these are some of the screenshots of what we have contributed back for Cloudbreak with respect to the Keystone version. It now this is available also on the public instance of Cloudbreak. You can go ahead and select Keystone version 2 or version 3 depending on your environment, and it will also have all the scopes for Keystone version 3 supported there. So for custom AMI support, what we see on the right-hand side is what Cloudbreak has by default in the repo. It uses these AMIs. We replaced this with our own AMIs. We worked with the Cloudbreak team to understand the prerequisites for Cloudbreak and helped and bake those in our images. This helped us to use our hardened AMIs, which allows us to do volume encryption using Lux, have enhanced networking enabled, and have some specific configurations in SSSD and other places like LDAP, repos, etc. Also, apart from this, the non-Dockerized HDP support. So we didn't, all our clusters before using Cloudbreak were running plain vanilla HDP directly on either bare metals or OpenStack VMs. We didn't have any experience running production clusters under Docker, so we wanted it to be the same. So Cloudbreak team developed this feature wherein you can have Cloudbreak install HDP directly on the infrastructure rather than having it installed on Dockerized containers. We are using that feature. We tested this out when this feature was developed in our environment, basically acted as a QA for Cloudbreak, and this is now available in the master branch. So then comes, this is a feature that is not yet available in Cloudbreak, I believe. What we did is we basically changed the CloudFormation template and built Cloudbreak from trunk by changing some of the features, some of the attributes in CloudFormation, so that we have the root volume on the instance ephemeral storage rather than the EBS backed root volumes. We will probably be contributing this back soon as an option to Cloudbreak. And there are some other few other enhancements that we would want Cloudbreak to support, which we are working in-house. I believe placement groups is something which is already available, so we are mostly done with that. We need to support multiple security groups. So right now, all the entire cluster gets, you can select only one security group, and that applies to the entire cluster. But in some of our environments, we need to have more than one security groups applied to the cluster. So we are working on adding that feature. The entire HDP cluster right now gets deployed in a single subnet. So we are working to see if we can have some host groups split across subnets. And obviously, the support for non-EBS root volumes is something that we have seen. So this is all about the Cloudbreak work that we have been doing and how we are using Cloudbreak. I'll hand it over back to Karthik for monitoring and alerting.
Sure, thank you. So yeah, as you see, we are leveraging both SSA and Cloudbreak for both of our dev test clusters and staging clusters and production clusters. So we have actually started building our production cluster using Cloudbreak as well. So we are kind of using the same tool to make it easy for everybody to use. So what happens next, right? So we give this service to the users, to the developers, and they start building the clusters. The first thing they're going to ask us, how am I doing? How's my cluster doing, right? So we delivered this. Now they're like, okay, I see some issues. I submitted a job, nothing is working. What's going on, right? So we obviously needed, and we are obviously using the same thing for for our production clusters as well. So we started leveraging a lot of the Ambari features to build our own dashboards, and also started using extensively Ambari alerting for some of our needs. Right, so we have built a lot of comprehensive dashboards in all of the environments that we manage, and we have actually automated some of the stuff for our platform or our product team developers to use as well in terms of how they can build their own dashboards for their own clusters. And we extensively use Ambari alerts, and all of our dashboard are built using Grafana and InfluxDB at the back end. And OpenTSDB as well at the back end. And then we extensively use Ambari alerts for all the clusters that we manage. And then we also have our own homegrown synthetic transaction framework. We call it as QueryX. And it's basically a custom framework that will fill in the gaps that Ambari doesn't provide. So this is a very quick view, high-level architecture view of what our monitoring framework looks like. So basically, we have an Ambari metrics collector, and we also have QueryX that runs periodically. In most of the scenarios, it runs every 5 minutes. And then it calls, for all of the clusters that we manage, it calls the Ambari APIs to gather all of the metrics from those APIs, and then it pushes the metrics into OpenTSDB. It's basically a time series database that it pushes into, and then we have a Grafana dashboard built on top of OpenTSDB. Right. So this is a sample dashboard for one of our clusters that we built, right? So it basically tracks all of the jobs that are getting completed, how many are running currently, basically what's the health of the cluster at any given point in time, all that. And you can actually drill down into each of these, and you can actually, see that this could be a little bit hard to read, but it basically gives you the information about, how much HDFS storage is left, how much is being used, and things like that. But you can actually drill down into each of those. So we have, in the order of close to 50 dashboards that people can go look into things for the things that they're specifically interested in. And how do we, make sure that our clusters are available for the SLAs that we have defined it for? So we use Ambari alerts very extensively. We, along with the default alerts that are configured, that you can configure in Ambari, we also create, some of our own alerts. So alert groups. So for example, here you can see we have created a PagerDuty alert group that we wanted specifically to wake people up at 2 a.m. in the night. We don't want them to wake up for every single alert that comes in, but we figured out a few things that we want to make sure that people give attention to at any point in time. So we did that. This is an example of an Ambari alert. We actually did a lot of work on configuring some of the stuff. You can see this is if you're on call, you will get paged, but you'll also get this email, and this email will give all the information about the alert. It will also have, we have also modified it so that it has the link to the runbook and the wiki or internal wiki that has all the information about the cluster that we have built and whatnot. Right, so whoever wakes up at 2 a.m. has all the information in hand when they see that email. Right, so here's a quick summary and the future work. So this is definitely has been a journey for us. So when we started on about 2 years ago, I still remember it took us more than 3 or 4 weeks to build a cluster in OpenStack. Right now it's a matter of 30 minutes or 15 minutes. Right, so we're still evolving and hope to get better. And so we are definitely moving towards leveraging Cloudbreak as one tool for all of our cloud as much as we can, and we are working closely with the Cloudbreak team as well to contribute some of the features that we are working on. We definitely want to enable and use the auto-scaling feature that Cloudbreak provides, Cloudbreak and Periscope provides, and we are also looking into seeing if we can build one single large yarn cluster for a variety of compute and storage loads as well, instead of building some of these individual clusters as well. So some of our code are already open sourced. You can go there, github.com/Symantec. Our SSA code is already there. There is also some other code that we are planning to open source pretty soon, including QueryX and something else. So that's it. Any questions? Right, so great question. So let me just repeat the question. The question was, if you create all these siloed clusters for all the developers, how do you manage the security of the data if you start moving the data in multiple places? So our goal was we create very specific anonymized data set for these people to play around with when they spin up these individual clusters. So that's the data that they get. So this is primarily to isolate the new softwares and the new versions that they want to test with before it gets into the shared cluster. Right, so we also had these issues before where even in the dev test or a QA cluster where if you install something, if it's a shared between 10 or 20 different developers, it actually affects other people's work, right? So if you're working on something really on your own, it makes sense to silo them as much as we can. Sure. Good. No, so for those, we have our own automation scripts right now, but we have also written custom services within Ambari for MySQL as well. So most of it is MySQL for us, and we actually have a custom service that we wrote to install and manage MySQL in HA mode through Ambari. Right, so we pretty much try to use Ambari as much as we can for managing any of the services. Sure. It shouldn't be a lot. So basically, the framework is written in such a way that it's easily extensible to other cloud providers. So it's basically, we have a bunch of REST APIs that we expose. As long as you implement those specific REST interfaces, then you should be able to extend it to other cloud providers pretty easily. Sorry? Yeah, so the services are basically, spinning up a VM, setting up the network, creating the FQDN records, and beyond that, it's just installing Ambari and Ambari agents at that point. Sure. Version control within each of the environments. Right, so it is definitely a hard problem to solve for us. So right now we kind of in a place where we are actually trying to bring everybody into one version, but right now it's not easy to manage. I mean, we are managing it individually for each of those clusters, and as the developers come in and they want new services come in, then we have to upgrade that specific cluster that they want to deploy their service in. But it is not an easy problem for us to solve at this point. I am not sure. Do you know?
It does. It will add the DNS records to the configured host name. You can actually have the host name configured as per your DNS thing and have the. So what we did on our case was we baked the DNS and everything into the AMIs. So that way we used our own host name formats. Right. Yeah. So that's the reason why we used custom AMI, so that we can use our own DNS records baked in that AMI.
Right, so for us, we actually have our own infrastructure for DNS, LDAP, authentication, and everything. So we don't use any of the AWS provided infrastructure for that. Sure. Sorry, it's a little hard to hear, but I assume you're asking about the storage layer for different cloud providers? Right, so that's definitely in our roadmap. So we are looking into decoupling storage from the compute. Right now, we haven't really done that yet because of some very specific performance reasons that we are seeing on these clusters. But eventually, right now, we are actually having a POC going on to use S3 as the back end. Right, so once we can start isolating compute from storage, then it'll be easy to move on to other cloud providers as well. Yes, that's definitely in our roadmap. We're looking at it.
Mm-hmm. Not right now. So right now, we just created one single security group which has all the rules that we need for our cluster. But ideally, what we would want to do is we would have one security group which would have some fixed set of rules that needs to go for any AWS resource that we instantiate. plus the security groups for HDP clusters. So right now we combine them into one single security group and use that. But like I said, we would ideally want to have multiple security groups. So it's all in one subnet right now. We just created one subnet, and the entire HDP cluster is in a single subnet.
Sure.
Mm-hmm. They are a CentOS 7, and we, like we mentioned in the slide, they point to our own repo, which has HTTP, and from where it downloads the HTTP basically.
Yeah, it doesn't have any of the Ambari agents baked in.
Yeah.
We install them,
baked in,
right? But it is in our repo. So we have scripts that will install it from our repo.
Yeah, Cloudbreak actually uses the key that you provided to provision the AWS infrastructure, and through that it actually spins up the VMs and other things. Is that the question that you have? Mm-hmm. So that is configured when we configure Cloudbreak to deploy the cluster. We add a key over there, which it uses to provision all the nodes, and it's available on all the nodes for that as well.
Yeah, so it basically bakes in the private key into all of the nodes that it spins up. No, we don't have Kerberos on these clusters yet.
But I think Cloudbreak supports Kerberos right now.
Right.
It does. We are not using it, but Cloudbreak does support Kerberos.
Right. So there were a couple of other talks earlier before us in the morning day. There were a lot of good features on Ambari and Cloudbreak that was presented in those talks. But we are kind of using a lot of those at this point, and hoping to use more as well. But yeah, there's a lot more new features also coming, like the dashboard that I was showing in Ambari. It's actually built into Ambari now, so we don't have to build our own dashboard. So hopefully we can start leveraging some of that stuff as well. But this is kind of our journey so far. Sure. Right. So for our private cloud, OpenStack Cloud, it's it's kind of easy for us to manage because we specify a specific quota for each of the product teams. So they come in as a specific tenant and they have a specific quota. So if that team has 100 VMs as a quota, then and if they have 10 developers, then they have to share that within them. But when it gets to AWS, it's a little bit tricky because it's charged after the fact. So we have tools that we are building right now to make sure that we provide that visibility back to the product teams to make sure that they're not getting overcharged on some of the stuff. But yes, it needs to be really looked into pretty closely at this point. Sure. Yep. Yeah, so I think assemblies will definitely help us, right? So hopefully if we can make use of that feature and if we can have one big shared cluster where we can manage some of these different versions in the same cluster, then obviously we don't really have to have developers spin up so many different clusters for testing some of that stuff. But that's something that we will look into and see if that's something that we can leverage. All right, thank you.
Thank you.